So hello everyone and welcome to today's LeetCode daily question, that is remove stones to minimize the total. So you have been given an array called piles, and where each index, that is piles of I, represent the number of stones in the ith pile, and also you have been given an integer k. So and you should apply a certain operation exactly k times. So what is that operation? You have to choose any of this number given, that is any of piles of I, and remove floor value of piles I divided by 2 from that particular pile. So as you can see, this example is given to us 549, that is piles 0 has 5 stones. The pile at first index has 4 stones, and also k is given. So our target is to minimize the possible number of total stones. So currently the total is 9 plus 4, that is 13, plus 5, so that is 18. We have to minimize this total after we have done we have done k operations. And the operation is to choose any of these piles and remove piles of divide by 2. So the basic things that which comes into our mind is to simply take out the maximum number, do this operation, reduce that number by piles I divided by 2, and do this operation until k is not equal to 0. So the same thing is there. I have taken out the priority queue over here. So priority queue by default will give you the smallest number, but we want the largest number. So I have used corrections dot reverse order. Now for I equal to 0, that is I will iterate through the array given to us. I will add that element to the priority queue. At the same time I will calculate the sum, since sum we have to return at the end. So the next one is while k is not equal to 0. So in the next loop we will do the operation k times. So what we will do at each instance, at each loop, we will take out the largest element, for example 9. We will do the operation, that is we will store this value, that is floor of piles I divided by 2, that is now piles I is the highest one, so a is there, because so a is that particular pile size. So we will store mat.floor a divided by 2 into the add variable. Then we will reduce that add from the sum, and then also we will reduce that number from the a what we taken out. Like for 9, if we took 9 out, so we will do 9 divided by 2 will be in add, so it will be 4. 9 divided by 2, so it will be 4. So we will reduce sum is equal to sum minus add. So sum is equal to sum minus 4, that is sum will become 18 minus 4, that is 14. And now the a variable, that is which was 9 earlier, will become 9 minus 4, that is 5. So and then at the end we will add that 5 again. So as you can see, at the end 5 was added again, and then we will do the same operations again and again. So now let me do the dry run and explain you how it actually works. So okay, so I've pasted the code over here, and this is the question. So k is equal to 3 and the array is 4 3 6 7. So in the first loop we will add the sum, we will add all these elements and store in the sum, and also we will add all the elements to the priority queue. So okay, so we will add this, and since it is collections dot reverse order, so it will be sorted in reverse order, that is decreasing to increasing. So it will be 7, then 6, then 4 will be stored, and then 3 will be stored. Okay, so and the sum will be what it, the sum will be 4 plus 3 plus 6 plus 7, that is it will be 20. Then we will move to this loop, that is while k not equal to 0. First we will take out a, that is the maximum. Now pq dot remove will take out the maximum element. Since it is corrections dot reverse order, it is sorted in the reverse order, so it will take out the maximum element. So okay, so it will take out 7 for now. 7. So now add is equal to integer, since mat dot floor returns a double, so we have converted to integer, and a divided by 2. So 7 divided by 2 is actually 3.5, so the floor value of 3.5 is 3. So add will be 3. So we will subtract sum is equal to sum minus add. So sum will become 20 minus 3, that is 17. and a will also be reduced by 3, so it will become 7 minus 3, that is 7 minus 3 is 4. So we will, at the end we will again add uh, a to pq, that is priority queue. So again, instead of 7, we have a 4 now, so 6 comes first now. Then we have two 4s. Instead of 7 we got a 4, and originally also there was a 4, and 3 was there, and the sum is 17. Now k is equal to 2, since it is reduced by 1 over here, so k is equal to 2. Then we take out the maximum element. Again 6 will be taken out, so 6, and add will be 6 divided by 2 floor value, so it is 3 itself. Sum will be reduced by again 3, since add is 3, so it will be now 14. And this element, so add a will also be reduced by 3, so it will be 3. We will add that element again. So instead of 6, now 3 came, so now it will be 4, 4, 3 and a 3, since instead of 6, 3 came, and 3 was already present. So it automatically fixes it, the priority automatically adjusts the value such that we get the maximum element first. So next one, now k is equal to 1. So again we take out the maximum element, that is 4 now. Add will be 2, and we reduce sum was 14, so it became 12 now. Okay, sum is 12 now, and also we will reduce 8 by 2, so it becomes 2. We will add 2, so now instead of 4, 2 came, so 4, 3, 3 and a 2, since 2 is the smallest, it will automatically go to the last. And now since now k was 1, so k minus minus, so k equal to 0 now. K equal to 0. So now since k is equal to 0, we will return, and at the end sum we have to return. So this sum is equal to 12 will be returned. Okay, so we will return that, and as you can see the output is 12 for this. So we will have to return a sum, and let me submit this now. So it is getting submitted, and thank you for being with me. And if you like the video, so do like and subscribe our channel, and thank you very much.